Hey everyone. I've got to tell you, as a robotics researcher, stepping out of the lab and into this design conference is an absolute thrill. We spend so much of our time tinkering with mechanics and code, but the real magic? That happens when these machines finally land in your studios. Welcome to this explainer. Today we're going to completely flip the script on the future of our creative tools. We're talking about a massive shift, moving from tools we simply use to entities we actively collaborate with. I want to kick things off by completely shattering an outdated stereotype. When I say the word robot, your brain probably jumps straight to those massive, rigid arms welding car doors on an assembly line, right? Well, scratch that. We are way beyond that now. As this quote highlights, robots are actively moving away from purely industrial, repetitive chores. They're actually evolving into intelligent collaborators in fields like art, music, and design. They're developing, well, taste, if you can believe it. They can now navigate the messy nuances of the creative process right alongside you. So here's our roadmap for this explainer. We're going to hit the cognitive revolution, the adaptive intelligence brain, robots as creative collaborators, the virtual creative factory, and finally, joining the robotic frontier.
All right, let's jump right into part one, the cognitive revolution, shifting paradigms.
To understand how a robotic muse is even possible, we have to look at this massive leap in robotics. On the left, you've got the old school, pre-programmed routines. This is your classic fixed manufacturing setup. It's rigid. It just repeats tasks. If you move a piece of metal 2 inches to the left, the whole system breaks down and your million-dollar robot is just aggressively welding thin air. Not great. But look at the right side. This is the new era, adaptive intelligence. We're talking about learning entities capable of dynamic problem solving. This jump from rigid to adaptable is literally what lets these machines step out of the factory and into the wildly unpredictable world of art and design. Moving right along to section 2, the adaptive intelligence brain, deconstructing the tech. Let's look closely at this definition. The key takeaway here is that adaptive intelligence acts as a central brain. It isn't just a rigid script anymore. It's a dynamic system that lets robots break completely free from pre-programmed routines. And why does that matter to you guys? Well, because let's be real, the creative process is chaotic. You pivot, you change your mind, you experiment. Adaptive intelligence lets the machine roll with those punches in real time. Even better, it actually learns from your unpredictable process and improves its contributions over time. You can basically think of these 3 steps as the anatomy of your new collaborator. Step 1 is computer vision. Those are the eyes. It lets the machine literally see its surroundings and identify the canvas or the specific tools on your desk. Step 2 is natural language processing. This is the voice and the ears. Instead of typing clunky code, you just talk to the robot intuitively, sharing ideas like you would with a human partner. And step 3, machine learning. That's the cognitive engine. It analyzes data, picks up on your specific design style, and remembers it for next time. Which brings us to section 3. Robots as creative collaborators, the Silicon Muse in action. All right, let's connect the dots and see how this tech actually helps you in the studio. This table lays it out perfectly. Take art, for example. Thanks to computer vision, a robot can safely interact with physical materials. It can hold a specific brush or even manipulate delicate clay without turning it into a pancake. In music, machine learning is doing the heavy lifting. A robotic system can analyze a musician's jam session and adapt its own performance to match their unique style on the fly. Crazy, right? And for design, natural language processing is an absolute game changer. You can just talk through your creative instructions, and the robot intuitively responds and assists in drafting your ideas. Now, I want to pause here for a second because this is absolutely crucial. Read that text. Enhancing, not replacing. I promise you, as robotics researchers, our goal isn't to build a machine that paints a masterpiece so you get to stay home. No way. The goal is to build a machine that takes on some of the heavy lifting, cognitive or physical, so your unique human creativity is amplified. This tech is designed to be your partner, not your replacement. Okay, let's look at section 4, the virtual creative factory, synergy in the machine. If you want to see what this synergy looks like in the wild, look no further than Franco Articeros and the Virtual Creative Factory, or VCF. I love this quote. He calls modern robotics a vibrant blend of artificial intelligence, mechanical engineering, and creative problem solving. And that is exactly what the VCF champions. They aren't just staring at motors and math equations. They're exploring how these machines can tackle abstract, highly creative problems side by side with human thinkers. And they've set up something super cool called the VCF Shared Gallery. It's basically a dedicated hub for human-robot projects. as you can see from these points, is showcases actual side-by-side collaboration. VCF members use the platform to blend natural language processing and machine learning for intuitive ideation. It's literally acting as the vanguard for creative innovation. This isn't just theory anymore, folks. It's happening right now in this gallery. And our final section, number 5, joining the robotic frontier, your next steps. So, the big question. How do you actually start using these tools in your workflow? Well, the VCF highlights a really important distinction here. We have to move away from passive observation, just sitting on the sidelines, watching the tech evolve and hoping it works out for you. Instead, we need active participation. By deepening your understanding and actually getting involved, you get to steer where these tools go. Think of it this way. Us engineers, we're building the hammers, but we desperately need you, the artists, to tell us exactly how you want to swing them. To get started, here are 3 practical steps. First up, grab a DIY robotics kit. Seriously, experiment with them. Even the basic ones are a fantastic way to wrap your head around the underlying mechanics. Second, check out some online courses on AI platforms. You don't need a PhD. There are tons of accessible resources out there. And third, find your people. Join communities like the VCF to share ideas. Networking with others is honestly the best way to jump into this vanguard of innovation. As we wrap up this explainer, I want to leave you with this final provocative thought. You've seen the cognitive revolution, you get the adaptive brain, you see how vision, language, and learning map right onto your specific creative fields. So, when you head back to your studios, your canvases, your drafting tables, how will you invite this adaptive intelligence into your workflow? How are you going to utilize your new Silicon Muse in your next masterpiece? Thank you so much for hanging out and exploring this frontier with me. Keep innovating, and I honestly can't wait to see what you create next.